Welcome everybody. I'm Lisa Morey with Colorado Earth, and we are here at the block yard facility where we make blocks, and we are going to be building a demonstration wall, sharing this with masons to learn how these blocks go together, how to install an earthen masonry wall. We're going to be building a window, we're going to be putting in the sill and the lintels, all the details that go into the full wall assembly. So here working with my mason Dave and some helpers that are going to be learning how to do this together with us. I hope you enjoy watching and working with us. Okay, we're going to start laying our double wall here. So with my hands at the blocks, we're going to be laying a 6-inch inner course and a 6-inch wide outer course, and leaving that 3-inch cavity for the insulation. So first we're going to be laying the inner course, the inner whites. We're going to be kind of getting the layout down right now, and we have kind of indicated where the rebar is going to go. So the engineer might have a spacing of 24 inches, 48 inches. It really depends on, again, the design. So Dave is getting the blocks laid out, dry stacked, and then we will be laying that first inner course here in just a minute. So the guys are making a mortar mix for laying the blocks. Again, I mentioned the mix in this case is about 4 parts adobe, which consists of sand and clay together, and then we're adding another 3 parts sand, masonry sand to that, and 1 part lime. And so that gives a really compatible properties to the blocks themselves. So the blocks and the mortar together can move together, perform thermally together, mechanically together. So a good mixing method is kind of the chop method. So little by little, you're kind of pulling it forward, slowly adding water. Once it gets all the way to the other side, come back around and chop, which means push little by little. You know, you'll find that the ideal consistency of mortar has the right amount of water that makes it workable, kind of fluffy. It's not stiff. You can add water as you're going throughout the day, kind of keep it, consistency. But like a thick yogurt consistency might be, a thick smoothie might be the right kind of analogy here. So what you're seeing here is this, Dave has run a string line from one side to the other, and I just leave a little bit of daylight between the actual block and the string, but this again helps you to stay level going across. We've all probably shown up at job sites and the foundation's been poured and we find that it's not perfectly level. Fortunately, with masonry, we can accommodate that and make it up as we go along. But it is really important to first check the foundation heights with a transit, ideally, once you arrive. So then therefore you know that you can build up the mortar join as you're going up. I recommend not going fatter than 3/4 of an inch for the mortar join, but again, it might take you 2, 3, 4 courses until you're actually have compensated for that missed height of the foundation itself. So always get a check. Your foundation is probably not level, assume it's not, and make adjustments as you go along. All right, we are putting down the metal flashing on the outer white, underneath the outer white. We're going to be using this Master Seal sealant to fix the metal flashing to the top of the foundation. The metal flashing, what it does for us is it directs any bulk water that might find its way in the cavity to the outside of the wall. So it's got a little bit of a drip edge here, as you can see on the outside, which is actually going to hang over the outer edge of the foundation. And we've snipped out where the vertical rebar is going to be placed just to make room for its placement. What we've done is a good idea, so once the wall starts getting not visible from the outside, is I've marked here on the outside where the rebar is going to be placed, so a circle there that's in direct line with where that vertical bar is going to go. So should that not be visible from the inside, you just can hit on the outer wall. are placing the membrane on top of the metal flashing and on the underside of the outer white of the block. And this is a roofing membrane, pretty thick gauge and very sticky. So we've measured it out that it's going to go along the outer white, which is 6 inches, and along the cavity, which is 3 inches, and then we're going to be bringing it up over the first course on the inside, and then actually folding it on top of the first course here. Purpose of this membrane is to direct any bulk water out from under the wall and direct it to the outside. Before you put the membrane down, the roofing membrane here, it's really recommended that you kind of measure and score it, and you can lay it into kind of different sections. So we're showing how we're peeling back the bottom section first, and then once that's placed here, then we can put down the top side, and this just helps us get it into place better. All right, if you remember, I had marked on the foundation here where the rebar hole had been pre-drilled. And so I'm just gonna kind of go back and try to find that hole here with the knife and cut where the rebar is actually gonna be placed in the membrane into that hole. So going along and finding where that rebar hole is and cutting a hole here where we're going to stab in the rebar next. Dave and I are about ready to place the rebar, epoxied into the hole. So you can see how it's starting to turn gray here in the top part of the tube. That's what we're looking for. It's actually mixing in that tube itself. So holes have been pre-drilled 6 inches into the foundation. These are number 4 rebars, and so these have been cut at 30 inches. So we are planning to have 6 inches into the rebar and 24 inches above, and that's the overlap height that we'll need for the next set of rebar that's going to extend up. So in the past, we used to actually have the starter bars coming out of the foundation and be generally on the spacing that the engineer wants. However, we found that with these blocks with the 2-inch diameter holes in them, it's really difficult and challenging to get them exactly where you want the coursing to be for the layout. So we always recommend now placing the bars after the fact and after you've done kind of a dry run layout of the blocks and placing them so that you know that they're coming in exactly at the coursing that they need to be placed at.
So normally what we do is we lay the EB dry with the mortar joint, and then we go along. It's supposed to be every 2 foot on center, but it's going to vary because of the block cell's distance, so we get it close to 2 foot as specified in the drawings. Then what we do is we drill a hole, we mark, you can see the paint in the cells there, we mark it with the paint so that we know where that diameter is. And we offset and we drill holes a little bit offset from the center so that when the next lap comes down, it has room within the cell and it's not hitting the sidewalls of the cell.
Another way to protect the wall, the bottom of the wall, from moisture and to direct water to the outside are these weeps. In this case, we're actually using rope, but they do make and manufacture kind of actual plastic weeps instead. But this actually works well. The idea is that the water is going to be wicked into the rope and then directed, channeled to the outside. So we're going to place it right here between 2 blocks and underneath where the mortar is being placed. And we'll put these kind of on like about 2 feet, 3 feet spacing. Dave here is cleaning out the cavity. This is something important to do as you're constructing the wall. As you can imagine, all that excess mortar or mud in the cavity is going to displace the amount of insulation that's meant to go there. As you go up, you can clean it out this way. There are some other kind of tools and methods that you can do to kind of put in, devices that screed or kind of clean out the cavity as you're going up. But again, just find a way that works for you and your team to keep this cavity clean as you're going up, so that the insulation has the best opportunity to do its work.
You want to make sure, coming off the foundation that's assumed level, that you do these block in increments of 4 inches. Now some of the blocks may vary in thickness due to the shrinkage, so you got to take that into consideration. So this last block I laid is a little bit low to 4 inches. And this one here, coming off the foundation, so I'm a 1/4 inch low. And that could be block size, could be I didn't put enough mortar underneath it. So I'll have to pick that up, assuming the foundation is level. So I'll add more mortar on the next course to get there.
All right, I want to talk about the importance of tuck pointing and why we do it. Because this is a double wall and we have the insulation in between, we want to really make sure as we're building the wall that the joins themselves are complete. As you can imagine, perlite is very loose and flowy, and so when it's strong winds or when the perlite pipe can find its way out, it will. So where the mason has kind of laid the blocks and we find that the joins are not that complete, using the tuck point tool, kind of coming back in here and filling in. This is something that could be done after all the blocks are laid, but it's certainly easy to do it here. Have someone come behind and take care of this while the wall is being constructed. To lay a block with the mortar kind of already down, you want to place the outer edge of the block to the string line while holding the block. And once that edge is down where you can see daylight, and I know that this block is level, having checked it before, so we're setting it right to the string line, and then I can fit the back side of the block down using the back side of the trowel, just tapping it lightly into place while holding the other parts of the block so it doesn't move as well. That looks pretty good by eye, and I will check it. We are about to set our first electrical box into the wall. Typically you want to buy 4-inch tall electrical boxes because that's going to fit our coursing. But in this case we're working with a 3-inch one, which is fine. We're just going to build up the mortar bed around it. So we have an elbow on here that we want it to kind of be able to kind of be clear and access into the cavity of the wall. So this can be set out. In this typical case, we have about 7/8 inch of exterior plaster that's going to go on the exterior part of the wall. So this box could be set out. You could have a plate around it to accommodate for that inch plaster. In this case, we're going to set it right here, kind of flush with the wall, so this elbow is kind of sitting right here in the middle of the cavity.
Because there are blocks of crumbling sometimes on the floor.
We are getting ready to cut a block that's going to be placed here to accommodate where we just placed the electrical box. And so in order to stay on course and to know what size we're going to cut it, we made a block here. We made a line on the block exactly in the middle, but we want to go 1/4 inch on either side of that middle to accommodate for that's where that mortar joint is going to be placed vertically. So the distance between the edge of the block and The first mortar join line is 10 3/4 or so. And so that's what our next block is going to be cut to keep us on running bond course. On the note of production, a lot of masons want to know what their typical production time will be with this wall. We've had crews run about 5 masons with 2 tenders, and they're running about 1,000 blocks a day with this. Obviously, there's going to be some variables with that, but that is kind of typical. Yeah. We are at the top of the 4th course, and as per the engineer's drawings, they like to see Durawall placed at the top of each 4th course. So this is Durawall. It's a horizontal reinforcement. It's like a ladder, and it comes in different widths. Typically, we're using around a 10-inch wide Durawall. So again, this is us mechanically tying these 2 wall wipes together. It has enough space between that all our insulation can kind of still be filled into this cavity. Remember, every 4th course is to place your Durawall between the courses. All right, a lot of people are interested in how we insulate the cavity of the wall, and because of the Durawall that's between the courses, we have to have something that's loose fill, something that we can easily put into the cavity. So perlite is one of our options, and I have a bag here. You can see it's like very lightweight. So we have about 3-inch cavity, and we're getting almost an R11, R12 out of that cavity with the perlite. Other options for insulation include loose fill cellulose, and there's some other manufacturers coming out with hemp wool loose fill product that we're excited about, but there are some wool products also available. So this provides us our R value in the wall assembly with the insulation, and helps kind of retain that heat in the inside wall. We are at the stage now where we are going to be attaching the outer buck to the wall itself. And previously we had installed an inner buck, a wooden inner buck to the cavity, and attached the outer buck to that inner buck. But now we're going to be using these T-ties here. So really kind of tight system. We've got the vertical rebars coming in. We are about to grout them in place, and then this will be slid over and again anchored to this inner buck. The recipe for the grout that we're using for putting in the rebar is a 3-part masonry sand, 2-part lime, and 2-part Portland cement. And lime is actually a type S hydrated lime. Why we like this T system is mechanically, structurally, it's stronger, keeping this window buck in place, and also thermally, it's allowing the insulation to come all the way up to the inner buck itself. The nice thing with lime mortar, without using Portland cement in it, is that it really can stiffen up and slowly throughout the day, and you can add water as needed. So even a wheelbarrow of lime mortar can be repurposed and used again the next day by adding water to the consistency that you want. So here, this is just a little bit stiff for laying blocks, so I'm just adding a little bit more water. Again, we kind of want it cow patty consistency. are at the top of wall, and you can see our angle iron set here, and the second one on the other side. There's still about a 3-inch cavity between. So we have cut some pieces of foam, rigid foam, that are going to be placed right inside this cavity, helping with any cold that's trying to escape. We want to kind of keep it in the building here. Then we're going to be ready to fill in our perlite. But first I wanted to show we have our conduit coming up. We put in a light switch here on the other side of the wall, and this conduit is from our outlet that we put on the exterior part of the wall here. We're about to form 2 more courses above this wall, and then we'll be pouring our bond beam. We want to flash the top of window or the lintel, and we're doing so using this flashing membrane, commercial grade, and we've kind of scored it to be able to bend it easier. So what we're going to do is we're going to do alongside the angle iron, and then up here this vertical edge, and then we're going to go back, and then we're going to come up and tie into the top of wall. This is actually our top of block wall. So we're going to be flashing this way so that, again, any bulk water that finds itself into the cavity is going to be directed to the outside of the wall. We are placing our weep tubes above the lintel. And again, this is another waterproofing flashing detail. So it's just going to be placed on our flashing in the mortar. We are waterproofing the window buck with this liquid flashing membrane called Max Flash by Sika. And we buy it in sausages, we apply it with a gun. It is knife grade, so we're using a putty knife to apply it. And again, it is adhered, or we apply it to all the exterior edges of the wooden window buck. A ceremony and a tradition with masonry in ancient times was to leave something of value in the 4 corners of the wall. And it's meant to bring good luck to the construction, to the people working on it, and of course the people that are going to be living in the home. We like to typically leave a coin of any denomination. You can leave a stone or anything of value, and again, we're just going to place it in the mortar joint at each of the 4 corners and hope that it does a good service to us. Before you finish kind of topping out and taking all your scaffolding off, I'll just make sure that you filled in all the joins. And so again, this is a way to contain all the perlite. We don't want to have there be kind of a wind situation which is pulling the perlite out of the wall. So some stiffer mortar works well, and again, just tucking in all your mortar joins flush. The conduit is coming up through the cavity, and it's going to extend all the way through the bond beam and have an elbow on it to return to your, in this case, floor joist or roof rafters at the top of wall. But if it's coming through your floor joist, then it's going to continue on and connect to your electrical box source. We are at the top of the earth block wall, and we're getting ready to describe how the bond beam works. And the bond beam is a really important structural part of the wall. Its first word of bond beam is continuous, meaning that it's going to be a ring around the entire top of the wall. It can step up or up gables and step up different heights if it needs to be, but the main thing is it needs to be continuous. So in order to create the bond beam, we use formwork to kind of encapsulate what we're going to later pour. And in this case, we've ripped down some plywood. Typically the bond beam is as wide as your wall, so in this case 15 inches, and the engineer will dictate the height, but it's usually around 8 inches tall. It's reinforced, and so there will be a specified reinforcing system to the bond beam itself. Remember, our vertical rebars are coming up into the bond beam, and it's going to be tied, attached to our horizontal bars. They will be supported on 2-inch chairs. Again, it's usually like a cage system, or depending on what the engineer dictates, which is all dependent on your seismic zone, wind load zone, design, height of wall. and other factors. So forming the bond beam with plywood, we have this wire, in this case, that's holding it together. So you want to have at least kind of 4 inches below the wall and the height of the bond beam. In this case, we're just doing a demonstration, so a shorter one is what we'll be doing. While we're at this stage also, this is when we want to pour in our perlite, and hopefully it's a non-windy day for you. It's going to fill this entire cavity. In the case of a single-story wall, where we are at the top of wall or bond beam, then a top plate will sit on top of that, and that's where all your roof rafters will connect to. If we were in the instance of this was a 2-story building and this was a bond beam in between 2 floors, then we would have bolts all thread coming through the bond beam and extending out into the interior part of the wall, about 1.5 inches or so. And this is what your floor joist will connect to on that inner side. Okay, here I am with an Alpen window that we're going to be setting into the wall, and this has been donated by our friends over there. They have a manufacturing facility in Boulder. Mostly windows have been seen as like holes in the wall where a lot of our thermal performance is lost. However, this is a triple pane window and it's got a U value of 0.2, so it does a great job at keeping the heat in and out when you want it. So this is a 2-foot by 3-foot window and we're about to set it into the wall. There's different options also with your sill. In this case, we are going to be using a stone sill, but it's best to use one piece and rather than a couple pieces that are attached, because that allows moisture to find its way inside. But before you place the sill, use your roofing membrane that we used above the lintel and fold it up under the window flange as shown, and then you can place mortar and your sill on top of that. And your sill can have a bit of a pitch directing outward to any snow or water that might be finding its way sitting on that ledge can find its way off. The plaster in our case is a lime plaster finish to the wall, and it's about a 7/8 inch 3-coat system, and it can kind of come around and finish into the trim of the window, and it also can come around and finish into this angle iron lintel. And you can have your angle iron be painted the same color as your plaster finish so it matches. But it's a really important way to protect these walls from moisture, and lime plaster does a really great homogeneous job with adhering to the earth blocks and allowing that water vapor to kind of transpire in and out of the wall itself. Okay, so the purpose in making this video was to show, demonstrate, teach masons that already know how to lay block and brick, but probably haven't done a wall system exactly like this before. So my goal is to have more masons that know how to do this, that understand the wall system, and that can give bids for projects that are coming out. Please reach out to us if you have any questions. We are here to answer them and provide any assistance to your questions that you have in the assembly and the product itself. We are making blocks right now in Brighton, Colorado, and have projects all around the Colorado and Front Range area. I do hope that you've enjoyed it, that you've learned something, and that you are excited to get your hands on the product and work with this material. Thanks so much for watching.